So another way to write it would be like this. Limit as x approaches 1, x squared minus 1, x minus 1 equals 2. So it's profoundly different from what does this function equal to when x equals 1. No, this sentence or this mathematical language, if you translate it into English, means what does this function approach to from both sides, from left and right, if x approaches to 1 from both sides, what does this function approach to? And this function approaches to 2. Okay, now sometimes you can have a situation where from one side you approach one value and from another side you approach another value. For example, if I have this kind of function x and y, and then I just have a function like this, and this is minus 1, and this is plus 1. So the function here would be defined like this. So it would be minus 1 if x is smaller than 0. And remember, if it's just smaller, not smaller or equal to, but just smaller, then 0 is not included. But then 1 is when x is bigger or equal to 0. So now, because of this sign, 0 is included. So I have a void here and I have a point here. Now, of course, here you can see that you approach different values as you approach x0. You approach different values from the point of view of y. So the way I would write it is like this. Limit x as x approaches to 0 from the negative side, which is from this side, from the negative side, then yx would approach minus 1, right? So from the negative side you approach x equals 0, and then you approach y minus 1. However, if you approach if x approaches 0 from the positive side, so you put a plus here. If you approach 0, if x approaches 0 from the positive side, then y would be 1. So these are called one-sided limits because from one side you approach one value and then from the other side you would approach another value. Now, I have an exercise for you. Okay, just pause the video and try to solve it. Okay, well, if x approaches infinity, which means it goes infinitely an infinite distance in the direction of x, well then you can see that the function would approach 0. It would never touch 0. It would never touch y equals 0, but it would approach y equals 0. So that's why when x equals 0, you cannot have a value for y because then it's undefined. However, as x approaches infinity, plus infinity, y would approach 0. Now if x approaches minus infinity, which is in this direction, then y would also approach 0. So the further I go, the closer this line gets to 0. So it would be 0. If x approaches 0 from the positive side, so from this side, then this value here, it would never touch the y-axis, but it would go further and further up because I would divide by a smaller and smaller number. So I would end up with plus infinity. So the correct way of saying is that as x approaches 0 from the positive side, y approaches plus infinity. And if x approaches 0 from the negative side, then y would approach minus infinity. And you can see it from the graph, and also you would divide by a smaller and smaller number. And just to make it a little bit more intuitive, like what does it mean that it never touches y equals 0? Well, let's say that if I have x here and y here, then let's say if I have 1 here. So that's my first interval. But let's say for the second interval, I take half of it, right? And then I would have 0.5. For the third interval, I would take another half. So I would have 0.25. For the fourth interval, I would take another half, which would be 0.0625. And I can go that on and on and on, and I can always take half of the previous value, which means that I will never quite reach 0. But if x goes to infinity, as x approaches infinity, the further and further I go, the closer and closer y approaches to 0. So that's the intuition behind it. I also want to show you very quickly a very special function in mathematics, which is this one, 1 plus 1 over x, and then all that to the power of x. The reason why it's so important in mathematics is because if x approaches to infinity, and by the way, this is not an exercise, I'm just showing it to you. As x approaches infinity, your function would be something like this, and it would approach a certain value. And that value that it will approach is the Euler's number. So Euler's number, which is 2.7, and it's also an irrational number. It has an infinite amount of decimals, but this is where it comes from this function. So as x approaches infinity, this term becomes smaller, but then you have this term in the power, which becomes bigger. And through a mathematical proof, it has been proven in mathematics that you will achieve Euler's number.